Welcome to the online causal inference seminar this week. So we're continuing our seminar series about causal inference and fairness. This week, we're very happy to have Moritz Hardt from the Max Planck Institute for Intelligent Systems. And the title of his talk is From Prediction to Power. Our discussant today is Michael Kim from UC Berkeley. The Q&A today will be handled by In, and she'll give a short update on how we handle Q&A.
Thank you, Qingyuan. So just as usual, please submit your questions through the Q&A section. It is a button at the bottom of the Zoom window. Please do submit it using the Q&A instead of chat for us to better track it. And I will bring the questions to Moritz from time to time. And without further ado, please feel free to start, Moritz.
Sounds good. Let me just share my screen real quick. All right, can everybody see it? Excellent. Yeah, thank you so much. It's a pleasure to speak at the seminar. Thanks everyone for getting up so early. That way us Europeans can join. And quick shout out to my collaborators who are also on the call. So Gabriele Carovano from the University of Tübingen and Celestine Mendler-Dünner from the Max Planck Institute. So what I'm going to talk about is fairness in a broader sense and certainly causal inference. So I think it satisfies your expectations at least 50%. And we'll see, I think there's a lot of interesting stuff related to what you're thinking about. So let me go ahead. And so, yeah, this talks about the causal effects of algorithmic predictions and what they do in our lives. And so we know now that all sorts of predictive models drive consumption and shape preferences on recommender systems and digital platforms. Algorithms make markets and change labor conditions, as we know in the case of Uber and the gig economy. And machine learning moderates public discourse and redirects attention, as in Facebook or Twitter. And also all sorts of risk scores used across the country, especially in the United States, are allocating opportunity and changing life trajectories in all sorts of ways, as for example risk scores used in criminal justice and so on. So all of these things that we're thinking about are in some sense causal effects of algorithmic predictions. So it makes a lot of sense for a causal inference seminar to think about these questions. So what I'm going to do today is there's two sides to this. I'm going to give you a little bit of background on something called performative prediction. And you should think of this as a general conceptual framework to reason about the causal effects or causal powers of prediction in a supervised machine learning context. Okay. And I'm going to tell you a little bit how, some emerging results in that area and their relationship to economic models. But then my main application for this talk is about something seemingly different, which is how you measure power in the sense of economic power or market power in digital economies. Okay, and we're going to see how concepts from performative prediction are useful in this context and possibly an arrow in the sort of the quiver of ongoing antitrust investigations. And certainly how these lead to all sorts of interesting causal inference questions that I hope some of you might get excited about. And I think this is actually a fantastic area to apply causal inference in. And so we'll talk about these questions. So let's take a step back and think about how we use machine learning to make predictions, okay, just to get everyone on the same page. So the way that we do this is that we represent a population as a fixed distribution, D over data, features X and an outcome variable Y. And so this is the typical assumption machine learning. I have this distribution, and then you're trying to find a predictor, theta X, so a function of your features that minimizes some loss function on the distribution, okay? So this is called risk minimization. And the risk is just the expected loss function or the expected loss of your predictor on the distribution, okay? So the expectation is taken over that fixed distribution, which always sits in the background. And much of supervised machine learning is about how to find a predictor theta given a sample or a sufficiently large sample from the distribution. And so that's not what my talk is about. My talk is going to be concerned with questions that sort of make sense at the population level. Okay, so the difference between the sample and the population is not going to be, the main point of my talk. So you're not going to see much about convergence rates. If anything, we're going to talk about questions that make sense at the population level. Okay, so we're going to identify some of the issues with this typical setup that already exist, even if you had infinitely many samples. Okay. So let's look at I apologize, there's a little bit of a lag when I click next on my slides, okay? So let's think about this for a second, right? So one thing that's implicit in the setup of supervised learning is that the prediction theta x cannot possibly influence the outcome y, okay? So why is that true? Because x and y come into being at the same time. They're sampled at the same time. So you think that y is determined at the time that the features are determined. Okay, so the outcome and the features are determined at the same time. So nothing you do based on the features could possibly influence the outcome variable. Okay, so in other words, we completely ignore whatever causal effects the prediction might have, whatever theta x might sort of trigger in the world, whatever causal effects. It is not subject of this framework. Okay, and so let me give you an example that kind of drives home why this is a bit of an issue, right? So let's think about a typical machine learning application, like predicting watch time of YouTube videos. Okay, so this is how YouTube ranked content as of a few years ago. They would take all sorts of user and video features, and from that predict like how many minutes the user would spend watching that video. Okay, and so here. Theta x is the predicted watch time based on the features x, and the outcome y is the actual watch time, okay? But now here's the catch, right? So this prediction, theta x, obviously determines the ranking, position 1, position 2, position 3 of content on the YouTube home screen, okay? And so the ranking in turn obviously influences what you're actually going to watch. If something is ranked 100, you're probably not going to see it. If something is ranked 1, you might be very tempted to click on it and watch it. So in other words, the prediction, causally influences the outcome. Okay, the outcome is not determined without your prediction. It's some kind of a function, possibly randomized function of your prediction and other things. Okay, and supervised learning just does not and cannot talk about this. It's just not somehow in the setup, in the formal setup of supervised learning to talk about this. Okay, and so you probably know some of these things already. So there's a lot of knowledge in economics and finance of why it's a bad idea to ignore causal effects of predictions. One of our favorite papers on this is a very old paper by Grunberg and Modigliani from 1954, which sort of introduced, this idea that predictions could be public or they could be private. Public predictions are things you announce to the world, which could influence the course of events, and private predictions are things that you keep to yourself. Okay, and so they articulated this difference very cleanly and sort of argued why you need to take into account what your predictions do. It's also related to all sorts of stuff in macroeconomics, like Goodhart's law and Lucas' critique, that I'm not going to go into much, but this is a recognized issue in economics, but it had been sort of, for the longest part, kind of ignored in machine learning, at least when it comes to building machine learning models. And so this is something we wanted to address when we came up with performative prediction, and we made a very simple assumption to get things started. So we postulate that when you deploy a model, let's say when you're YouTube and you're deploying a new ranking model, theta, the population changes from whatever state it was in, the distribution D, to a new distribution D theta. Okay, so the distribution now is a function of the predictor, is allowed to be a function of the predictor, and might vary with your predictor. So if you choose a different predictor, gives you a different ranking, that gives you a different distribution. People are going to consume different things based on your ranking, and so that's going to give you a different distribution over consumption. Okay. And so in other words, this d theta, think of this as capturing the aggregate sort of macroscopic changes in response to your decision rule. This is what happens to your population in response to your decision rule. You can think of it as the causal effect of the decision rule on the population, and we ignore all other effects that might be at play. There could be other things that change the distribution over time. We ignore that for now. We only look at the causal effect of the predictor, and we're interested in the causal powers of the predictor. Okay, just to give you a very simple example of what you can do with the setup, you could imagine that d theta is essentially the same distribution as before, it's XY, but you nudge the outcome ever so slightly in the direction of the prediction, okay? So when U2 predicts high watch time, so Y is large, then, that makes the outcome actually more likely, okay? Then your watch time, goes up a little bit because you're going to rank it high, and that's going to make it more likely that you watch it. That's a self-fulfilling prophecy. That's something you can write down in performance prediction that you can't write that down in supervised learning, okay? That's a simple example. It could also be negative, self-negating prophecy. That's also possible. And of course, more complicated things, we see some of them later, okay? And so once you have this formalism, you can write down what we call the performative risk, which is just like the risk, except that you evaluate your loss on the distribution that comes out of your predictor. Okay, so you take the expectation over d theta. So the expectation becomes a bit of a moving target. If you change your decision rule, you change the expectation. Okay, and so in practice, performativity often shows up as some kind of distribution shift after deployment. Okay, so your YouTube, you launch a new model, distribution changes, you retrain on that new distribution, you redeploy, data changes again, you retrain, and so on. Okay, so in practice, you often play this kind of cat and mouse game where you're trying to keep up with distribution shift by retraining the model. Okay. So let's see what follows from this kind of way of thinking about prediction, okay? So the first thing is this sort of fundamental distinction between optimization and steering, okay? So let me write it down this way. It's just a simple statement. Suppose the world is currently in a baseline state theta 0. This is the ranking model YouTube is currently deploying, and it gives you a distribution d theta, okay? And this is currently the data generating distribution that you're seeing. You can write your performative risk as the sum of two terms. Okay, this is not hard to see. The first term is just the standard risk. Okay, so it's just the supervised learning risk, the risk of theta on date d, the original distribution. And the second term is kind of how much you stand to gain by moving to this new distribution d theta. Okay, and I call this the performative advantage. And this is how much you stand to gain by nudging the population towards this new distribution d theta. Okay, so this is how much better your risk is on that new distribution. Okay, so in some sense, there are two ways to be good at prediction. One is just you optimize well in current condition. The other is you move to a distribution that is good for you. Okay, so you can do two things in performance prediction: learn or steer. Okay, and so yeah, performative risk equals sort of learning plus steering. Okay, this is a basic takeaway. And so, sorry, my slides are stuck again here. I apologize. There's sometimes a lag in my slides, and then it sort of builds up all at once. So if that happens, I apologize. So there are two solution concepts in performance prediction that make sense. The first is a notion of global optimality. Okay, so this is what happens if you just minimize the performative risk over all possible predictors. Again, this is a difficult objective. It's kind of a moving target. Not clear how you do that. There are some ways that we know now, but a priori, it's not clear how you do it. So you could try to minimize the risk, the performative risk over all possible models. But there's a different thing that makes often more sense, and that's what's called a stable point. So here you are, point is stable if risk minimization doesn't go anywhere. Okay, so if you were to collect data that's generated at a stable point and you optimize on that data, then your model looks optimal to you. Okay, so the data that you're seeing does not refute your model. Okay, so the data you're currently collecting at a stable point does not tell you that the model is suboptimal. Okay, so in other words, a stable point is a fixed point of risk minimization. If you do repeated risk minimization, like you often do in practice, you just keep retraining. A stable point will be a point where you stop because your model looks optimal to you. Okay, it may not be globally optimal. There might be some other faraway point that has smaller risk, but from the data that you're currently seeing, your model looks good to you. Okay, so that's a stable point. So by the way, feel free, I don't know how questions work. I missed the assumption, but the announcement. But are we interrupting or batching them until later?
We can do both. If you
Okay.
have like several points to stop, I can bring the questions to you. But for
Yeah, so
now, we
I
don't
don't think
have
I see
active.
them currently. So feel
Yeah,
free
yeah,
to like interrupt me or anything.
Sure.
Um,
Thank you.
Good. So given that we have optimality and stability, one of the first things we wanted to ask when we came up with this is, how do you find an optimal point, or how do you find a stable point, right? So since we know that a stable point is a fixed point of risk minimization, you can ask, does repeated risk minimization converge to a stable point? Okay, we know it's a fixed point, but does it converge to it? And the answer is, under some assumption, yes. So, if you do this repeated risk minimization, what I call it, and you make some relatively strong assumptions that your loss is smooth, strongly convex, and this distribution map is not too sensitive, so it doesn't jump around too much with your predictor, then repeated risk minimization finds a performative stable point. So this is one of the first results in this new framework, where at least this kind of, it justifies this kind of retraining heuristic at least giving you some kind of stable point under some assumptions. And these assumptions are necessary, so without them you don't converge. Okay, and so this spawned a bunch of work on this on performative prediction in machine learning and the machine learning community. So there are now all sorts of results on this, and there are many good questions in this area. So we just saw the convergence to a stable point. You can ask the same about stochastic optimization. There's some results on this now. We can sometimes find even optimal points, not just stable points. There's a nice connection to bandit algorithms. People have studied more sort of complex models of distribution shift that take into account time varying phenomena and stateful distribution shift. People also have studied multiplayer performative prediction. So what happens if there's many firms predicting and they all have performative effects? And we also looked at sort of performativity, from an empirical perspective, in the context of risk scores used in education. Okay, there's a growing literature on this topic.
Hi, Moritz.
Yeah.
There is a very quick clarification question.
Sounds great.
Is the stable point unique?
No, it need not be unique in general. In the case of a strongly convex loss, under these assumptions, it's unique, but it's not unique in general. But yes, under these assumptions, it will also be unique. Yeah.
Thank you.
Great. Thanks for the question. And so one thing you might wonder is, where does this distribution map come from? Okay, all of these results talk about kind of these aggregate changes to the population when you deploy a model, but where does this distribution map come from? How do we make assumptions about the distribution map? And there's an interesting way of doing it by sort of deriving this distribution map based on how individuals respond to your predictor. Okay, and so this is the route taken in this area called strategic classification, where you assume that the distribution map d theta comes from the strategic behavior of individuals that are trying to adapt to the decision rule. Okay, so individuals know your decision rule, they're scrutinizing the decision rule. Let's say you're a YouTube content creator, you think hard about YouTube's ranking algorithm because this is your business. So you think about what is the YouTube ranking algorithm doing, and you adapt to it. If the YouTube ranking algorithm rewards videos that are longer than 15 minutes, you're going to say, okay, I'm going to start producing videos that are longer than 50 minutes. Okay. And so what are these assumptions exactly? Just the standard assumptions, standard economic microfoundations, as they're called. So you assume individuals are rational, utility maximizing. You assume that there's basically sort of a single agent that's representative for the whole population because they're all optimizing alike. And so there's no need to distinguish between different agents. These agents, or this agent, computes simply the best response to your decision rule given available information. Okay, and so this is what started even before performative prediction, called strategic classification. There's been a lot of follow-up work on this topic. The advantages of these assumptions is that now, well, it's like this from econ. Now you have a very precise understanding of what happens because people are rational. You know what they're going to do, and so you can come up with all sorts of results. There are all sorts of ways of finding performative optima. In this context, they're called Steckelberg equilibria, and you can vary all sorts of assumptions cost functions, model families, approximate best response, etc., online setting, all sorts of stuff has been studied here. And you can always find these optima because you have this kind of nice analytic characterization of the distribution map. Okay, but there are also some serious shortcomings that we noticed when we worked on this. It's basically often a poor description of empirical reality. So these kind of assumptions predict behavior that you don't often see in practice. There's a high negative externality if you implement the optimal solution, a notion called social cost. And the optimal solution is very non-robust to non-strategic behavior. So the moment that some agents fail to be strategic, everything breaks down, okay? And so, you get all sorts of weird stuff that I'm not going to get into. Okay, but the takeaway about performativity so far that's going to be relevant for what I'm going to talk about now is, okay, so take this away, that strategic classification is just performative prediction plus these standard econ assumptions. And so what you should, appreciate so far is that, once you know about performativity, you kind of start to see it everywhere. Like you look at YouTube, that's performative. You look at all sorts of like other online platforms, all their predictors are performative. So everywhere you look, this kind of pops up, and it makes sense. I would sort of go so far, and you can try to refute me. I would say that any social prediction problem, any prediction problem that you do in the world, that you perform in the social world, is performative, because the whole point of doing the prediction is so that it has an effect. Okay, so this is the whole point of why you're in the business of making predictions anyway. Okay, and so performative prediction gets at this difference between learning about a population and steering a population towards a desirable state, a state that's desirable for you. Okay, and so there are two ways to be good: learning and steering. Okay, and this is the main takeaway so far. But even if you believe that every prediction problem is performative, there's still this question of how performative is it? Okay, so how much does the population respond to your predictor? If I make wild predictions from the convenience of my office, probably not too many people are going to react to it, and it's not very performative. If YouTube changes how they compensate content creators or how they rank their content, probably a lot of people are going to change in response to it. So the strength of performativity is, intuitively speaking, sort of dependent on the power of the firm that's making the predictions. Okay, so if people don't have outside options or don't have anywhere else to go, they're more likely to adjust to whatever you're doing with your predictions. Okay, so we're starting to think about how does high performativity sort of occur. And it turns out it always sort of does when the firm that's making the prediction has a very dominant position in the market. Okay, and so we're asking, how much can you actually infer about the power of a firm based on the performativity of its predictions? Okay? And this shouldn't sort of surprise you that there is this connection, because, if you look in the dictionary, power is defined as the capacity or ability to direct or influence the behavior of others. Okay, so this is like, power is basically the flip side to performativity. Okay, and so we're wondering, can we use performativity to reason about the power of predictive systems? Can we somehow measure how performative something is and then make inferences about how much power the predictor has? Okay, and so we were sort of developing this perspective in the context of digital platforms. Okay, so that often operate using predictive models. Think about various online platforms where content is ranked by a predictive model. And so these digital platforms are tricky for current antitrust frameworks. We're certainly not the first to observe this. There are many reports to this effect. There was like a long report by the Stickler Committee on Digital Platforms that talked, wrote all about like why this is very tricky. In particular, market definition keeps coming up as like a hurdle to applying like concepts from economics to these digital markets, because they're just different from classical markets and things are more complex. Okay, and so the European Commission also had, like in the same year, a long report calling for less emphasis on the analysis of market definition and more emphasis on theories of harm and identification of anti-competitive strategies. So they're trying to say, let's make this less about what the market is exactly and more about identifying patterns or strategies that are anti-competitive. Okay, and you might know that in Europe there's a lot of legislative activity around this, in particular the Digital Markets Act that's trying to regulate competition in digital platforms or markets. Okay, so that's the concept you should think about, or the context you should think about. And so we came up with a definition, this joint work with Meena, Jagadeesan, and Celestine, Mendler-Dünner, called performative power that builds on performative prediction. And informally speaking, the definition is simply that performative power is the largest change to a population that a firm can cause with respect to a given set of actions. Okay, so it's how much you can move a population with an action that you can perform, and we think of this action typically as a change to your algorithm. Okay, so we're thinking about like firms that operate in digital economies. Okay, but the thing that I want you to appreciate up front before I get into the formal definition is that nothing here is going to require sort of market definition. We don't need to know even which firms are in the market, what the prices are, or what kind of products are in the market, what sort of the reference equilibrium is, or anything like that. So we're going to go about it differently. We're going to talk sort of directly about the causal effect of actions that a firm can take. Okay, and so this makes it different from some of the standard tools in the antitrust literature, like the Lerner index, where you need some kind of reference equilibrium price, and that's kind of hard to do if you don't have a market definition and so on. Okay, let me give you an example of how to apply this definition, still somewhat informally, but we're sort of backing out the formal definition. I'm going to state it. And this is about Yelp reviews. I know that in this day and age, Yelp is probably not, doesn't look too much like a monopoly anymore. But back in the day, when Yelp was all the rage, you could have asked, does Yelp have too much power over, let's say, restaurants in San Francisco? And so you could choose, a population of units at one end of the power relationship. In this case, you might say restaurants in the US or, San Francisco. And you're going to look at an action set F that's sort of within reasonable agency of the firm. So here, in this case, we're going to choose the set of ranking models that Yelp could deploy. So this is all the possible ranking models that Yelp might, use. And we're going to pick a feature, a Z of U, of the unit of interest. And here we're going to use wait times at the restaurant as a proxy for how well the restaurant is doing. Okay, so if the wait times are long, then the restaurant has a lot of business. That's great. If there's no wait time, it's empty. And so the key thing is to look at this potential outcome of this feature ZU under a hypothetical action of the firm. Okay, so we're going to look at the potential outcome ZFU of the wait times if Yelp were to deploy this ranking model F. Okay, so this is just a potential outcomes variable where the treatment is the deployment of a ranking model. Okay, so for every ranking model, there's a potential outcome of the feature of interest under that deployed ranking model. And so then we're just going to look at the manifested versus counterfactual wait times. Okay, the difference. Okay, so we're going to look at the expected difference, expectations of all restaurants, and randomness in the potential outcomes. The expected difference between the wait times right now and the wait times if Yelp were to deploy some other ranking model. Okay, this is the example of how to apply this to Yelp. And so let's make it more formal. Here's the formal definition. You can probably guess what it's like now. You fix a population of participants interacting with a firm. This could be restaurants or content creators or Uber drivers. And you look at a set of actions that a firm can take. We typically think of these as predictive models that the firm can deploy. You look at a feature of interest or a set of features for each participant in the population. And you're going to look at this family of potential outcomes that represents for each participant the counterfactual feature under the hypothetical action. Okay, and so then the performative power of the firm with respect to the population, the action set, and the potential outcomes is defined as the supremum over all possible actions of the expected distance between the feature and the counterfactual feature. And here, this distance, as you saw in the previous example, it might just be an absolute value. It doesn't have to be anything fancy. It could just be like an L2 norm or an absolute value or something more sophisticated depending on your application. That's not the important part. The important part are the potential outcomes and the supremum, okay? And the action set, of course. So, but it's important that we have a supremum in the definition. So it's in some sense about the potential to cause something, you know, it's the supremum over potential actions. So it's things that are at sort of in the vicinity of the firm's decision-making, okay? So here's a key property. So I'm going to walk you through a couple of theoretical properties of this definition to convince you that it kind of checks out as sort of a definition of power. And then I'm going to tell you how to estimate this definition, or how to instantiate this using a few different causal inference designs. Okay, and I'm not going to need much more time, so we're going to be okay. So yeah, the first property that's relatively easy to show is that low performative power implies that the best a firm can do is optimization on current data, so learning, and there is no gain from steering. So if we're in some kind of baseline state that gives us a distribution, and we look at the optimum in this baseline state, the supervised learning optimum, and contrast that with a performative optimum, then we can see that the risk of the supervised learning solution is upper bounded by the risk of the performative optimum plus the performative power, okay? So the difference between the supervised learning and performative optimization is upper bounded by performative power, okay? And so think of this as analogous to price taking. If you have zero performative power, the best you can do is optimize in current condition. There's no gain from like price setting. So you can't like move to like some other distribution. It's just not something you can do. The best you can do is optimize in current conditions, okay? And so that's one property, but there's a lot more you can actually show when you plug this into the strategic classification setup. You can show that a monopoly firm maximizes performative power, in which case participants are willing to incur a cost equal to the utility of the service. They're willing to adapt until they have no more gain for themselves. A firm's ability to personalize more accurately increases performative power. So if you can index individuals more accurately, as you can do with targeted advertising and so on, that increases performative power. Outside options, on the other hand, decrease performative power. So if the firm's there that offer a similar service, you decrease performative power. And finally, there's a result that says when platforms compete over users with services that are substitutes, perfect substitutes for each other, then already two firms lead to zero performative power. And this should remind you of something, from like an econ lecture. It's basically like an analogy to the Bertrand competition. Okay, so it kind of recovers this famous Bertrand competition that if you're simultaneously setting prices, you get the zero profit solution, okay, with perfect substitutes, because the moment you're sort of like pricing it a little bit too high, everyone's going to go to the other firm, okay? And so something similarly happens to performative power, okay? So you already get zero performative power with just two firms in that case. So what does that have to do with causal effects? Like, how do you go from like causal effects of predictions to estimating performative power? So how do you use like tools from causal inference? Let me go back to the Yelp example and then make it a lot broader. Okay, so here's like a result that's known in the literature. And it's the typical kind of result that like econometricians or like market scientists or whatever will have, like marketing scientists will have like come up with. Okay, so here's a result by Anderson Magruder from 2012, which shows that an extra half-star rating causes restaurants to sell out 19 percentage points, so 49% more frequently. Okay, so that's a causal effect. They did this using some regression discontinuity design. They're saying if you had that like extra half-star, you'd sell out 50% more often. But what does that have to do with performative power? So if you think about it for a moment, remember that performative power talks about the supremum of Yelp's action. Okay, so you could take this, you can instantiate that supremum with the action, Yelp's action that corresponds to perturbing scores around the half-star threshold. Okay, and we know that, so this has like a high effect, right? If you move somebody from like 3.5 stars to 4 stars, that has a huge effect. So if we entertain the hypothetical action where Yelp like randomized or like swapped restaurants around the 3.5 star threshold, you would see a huge effect. Okay, so you can take Z to be the restaurant's feature of interest, that comes out of this result. Here, number of customers or how often you sell out. And then you can plug in this result from the literature as, one of the hypothetical actions that Yelp can take. Okay, and that way you get a lower bound on performative power. Okay, so every sort of causal effect like this gives you like sort of a statement about performative power. Okay, let's work this out in another example. And this is what I call the causal effect of position. And it's going to be quite relevant for the last point I'm going to make. So what's the causal effect of position? Well, online platforms display scores through content position, typically, right? So ranking, ordering, selection, arrangements, Google search results are ordered in a certain way. Tweets, Facebook posts, they're all ordered. So typically there's some like relevance score in the background, but we're actually seeing is like an ordering based on that score, okay? So you can define a causal effect of a position as basically the expected difference between the potential outcome under position 1 and the potential outcome under position 0. Okay, so imagine you have this box for the advertisements. Position 1 is that the box is at the top, and position 0 is that the box is below the yours on the side, or is like below the first results or whatever you want to compare. Okay, so you have two positions that you want to compare. The causal effect is this. Okay, so there's a theorem we can prove which says that assuming no interference, so sattva, the causal effect of position beta is a lower bound on performative power. Okay, so you can always lower bound performative power by studying these kind of position arrangements. Okay, and the trick is the same that you just saw in the Yelp example. We're going to take the firm's action to be the treatment in the definition of the causal effect of position. And then we're going to use the non-interference assumption to extrapolate that causal effect from a single unit to the population. Because there's no interference, we get to add up the effects, and we get useful lower bounds on performative power. For example, we did this in the case of targeted advertising, and we can show that the performative power of targeted advertising on Google is 20% of the baseline click-through rate. Okay. So in units of the baseline click-through rate, you can move things by 21%. Okay, and this is something you just get for free by using this this theorem. Okay, from like known results. In this case, a result by Narayana and Kalyananam. Good. So now let me wrap up with a few minutes I have left and talk about how any of this is relevant to antitrust. Because you might say, why a causal effective position? That seems like it's kind of a technical thing. And so what if I told you that this is at the heart of like one of Europe's largest antitrust cases, which is the Google shopping antitrust case. It's been ongoing since 2010. And in 2017, the European Commission announced that they thought Google had infringed on some, the article that regulates competition in the European Union by using its dominant position in search for favoring its own shopping results. Okay. And over like the results of other comparison shopping sites at the time. And so the key technical claim that the European Commission brought forward is that the arrangement of content steers traffic towards Google's own offering away from competitors. Okay. And at the heart of the case, if you dig through the hundreds of pages of this antitrust case, at the heart of it is a study that estimates the causal effect of position, which we know by the previous result, lower bounds performative power. Okay, so in ongoing work with Celestine, Mendler-Dünner, and Gabriele Carovano, who are both on the call, I think we sort of explore how you might use performative power in the context of European antitrust cases as like giving you basically sort of the causal effect that you're going to use in these cases. Okay, so my collaborators summarized 400 pages of like the Google antitrust shopping case in one slide. It's a pretty dense slide. And I'm probably not going to go through all of it, but basically it's quite interesting. So I'm just going to maybe like leave this for the discussion. So again, there's a whole lot of stuff that happened. They found an abusive conduct. They determined how it was anti-competitive. They brought forward a lot of evidence, but the key evidence was this position bias study. And Google was like responded with some other causal inference results of their own. But at the heart of this like 400 pages of argument is this position bias stuff. Okay, and so that we now know is just a performative power in disguise. Okay, and so just to wrap up, what's the role of performative power? I think of it as sort of trying to get at the causal question at the heart of an investigation. Of course, there's a lot more going on, and like the actual case is always going to be 500 pages of something, but let's be clear about the causal question you want to ask. And I think this is where performative power is going to be helpful. And it focuses on the effects of the causal effects of the firm's action. You have to specify only units and features of interest. And these features and units determine whether, you know, the power is harmful or not. So like harm is different from power. Harm is the second question that you need to specify, or you need to investigate in a specific context. But what performative power can do to you is sort of the first step of getting the causal effect right. And that's why causal inference tools, you know, just give you a lot of ways to identify performative power, and we can basically use the whole repertoire of causal inference to estimate performative power. And so more broadly speaking, I think of low performative power, if you will, as kind of a conceptual alternative to competition. Okay, so instead of talking about competition directly, it's sort of a way that lets you talk about something like competition without having to define markets, equilibria, and all that stuff. Okay, and I think that's an appealing aspect of this definition. Okay, so that's all. Thank you. I look forward to our discussion.
Thank you, Moritz, for your great talk. I think we still have time for maybe one question before we proceed to the discussion.
Yeah, so there's a question in the chat. You want to read it, or no?
Yeah, I'll bring it to you. So how did you estimate the causal effect of position or rating of restaurants in Yelp? What design did you use? There seems to be a possibility of regression discontinuity design given the discretization by half points.
That's exactly right. Yeah, so the Anderson-Magruder result used regression discontinuity, like just an RDD around the 3.5 to 4 star threshold. And we don't need to do our own regression discontinuity. I mean, ours is kind of using that, but we're just using the causal effect as a lower bound. So we have like an argument for why you can use these causal effects, kind of black box, to get a lower bound on performative power. So how you get that causal effect on Yelp, that's up to you. If you had used something other than RDD, that would have been fine for us. So we're not limited to RDD. You could have gotten that causal effect whichever way you want. So if you have like something very clever on like how to estimate position bias, we can use that. Okay.
Thank you for your answer. I think maybe we can proceed to discussion, and we can leave more questions to the end if we still have time. Michael, if you are, yeah, please feel free to
so I do see a few questions in the Q&A. Do you want to ask them?
Yeah, we can deal with it right now, but we can also like push it to the end of the seminar.
Either way.
Okay, let's do another one. There is a question in the Q&A. Are there significant difference between different economic or competitive systems? Does this perform well for monopolies and duopolies?
Yeah, so there is different. So one thing you can always do, and we started doing this in our theoretical results, is you take this definition and you plug it into your favorite market definition or economic model, and see what happens. Okay, we did this for a few different things, and we always get these results where it does what it should in some sense, but it is specific. It will do different things in different contexts. Okay, and so we have results about like monopolies maximizing performative power. We have a result where even two firms can lead to zero performative power, but that depends on the assumptions you're willing to make.
Thank you. That sounds super interesting. So we still have a question about tying performativity and firm's power. So it was suggested by our audience that the value of the prediction to the consumer is a critical mediator of any power. Yeah,
so this is a great question, and I think it gets at a very important distinction. that I touched on at the end, I think after this question was asked. So there's a difference between power and harm. I would completely agree. I would completely agree with Sasha that the value of the prediction, so the utility that the customer derives from the prediction, is essential to the question of, is the conduct harmful or not? All right, does it cause harm? So, but what we're tying, or what we're relating, is performativity and power. And power need not be harmful. Okay, you might have a lot of power in a way that we could consider decide is benign or is harmless. Okay, you could have a lot of performative power by simply entering the market with a vastly superior product that everyone switches to. That would not would be an example of performativity without harm. Okay, and so that's why it gives you this causal backbone of the antitrust question without resolving the question of harm. Okay, so for instance, it could have been like Google was simply steering people to like much better shopping results. Okay, maybe it was super performative, but like, hey, everybody got better shoes, and so we're not thinking that there was a problem. Okay, so the question of harm is essential. That's not something we can resolve in generality. That's a context-specific question. Yeah, that's a great question.
Thank you. We have a last question that just pops up. It asks, even with a lot of competitors, changing the position on the landing page will affect the CTR. It therefore seems to me that there is a disconnect between changing CTR and market power. What did I miss?
Yeah, so this is an interesting question too. So the way I think about it is, if you had a truly competitive like digital economy, you would have like infinitely many browser tabs. And the moment like on one browser tab, you see the item that you see does not maximize your utility, you instantaneously switch to the next item. Okay, so in some sense, the reason why the performance power is low in that case under competition is because if you're deriving this utility from what you're seeing, you can just go somewhere else. And so the click-through rate, in some sense, the position bias will be weaker if people have outside options.
Thank you. I think that's it for all of our questions, and it's a great time to start our discussion. Please feel free to get started, Michael.
Yeah, great. Thanks, Moritz. Thanks for the great talk. Really interesting stuff. I guess to start off, I think what's really interesting about this work is how it abstracts some key features of the problem and really makes brings them to bear, allows you to bring tools from optimization, computer science, statistics, to reason, causal inference, to reason about these problems, which is great. So, but one question that I was curious to hear you talk about, maybe we could jump back to the 400-page slide, if you don't mind.
This one?
Yeah, perfect. So I think I didn't have time to even read the whole slide, but it seems like here there's evidence brought by the European Commission and then separately experiments performed by Google, and that perhaps, I think you mentioned that they're each bringing their own causal analysis. They're each sort of saying, look, this looks like too much power. This looks like we're not changing things that much. In a sense, it seems to me that maybe the discrepancy here is a debate over what are the legitimate interventions, or what are the choice in your notation of F, or like capital F. And I'm curious how sort of both in a broad theoretical framework, as well as in sort of concrete examples, how you think about F. I think for Yelp, yeah, I really liked your example. I can think about also like recent examples of Twitter. Like probably we didn't think about like somebody coming in, taking Twitter private, and then firing half the staff as like a likely intervention. And yet here we are. So I guess I'm curious how you would choose F and how that affects how you reason about sort of the downstream measurements of performative power.
Yeah, that's a great question. So I think you asked two questions. The first one was sort of, in response to these allegations by the European Commission, Google brought forward its own sort of causal story of what happened, and how do we choose which causal story is sort of more convincing. And so I think in this case, if you look at sort of these bullet items here on abusive conduct, it was really two things that Google did. They changed their search algorithm called Panda, to sort of downrank results or websites that contained external content. And this really hurt any sort of comparison shopping site, because they have a lot of content from other sites because they're comparing other sites. And at the same time, they moved their own like shopping result box up high, where people could only see the Google Shopping comparison. And so it was sort of this double whammy of like, you couldn't get to the top in the regular results, and the box was only for Google. So there's just no way to like for these other shopping comparison sites to get up high. And so the experiments that Google sort of returned and were sort of like addressing one or the other, but not both in some sense. And so I think that was there was a bit of a disconnect between what the allegations were and what these experiments sort of responded to. But your second question still makes a lot of sense. Like, how do you choose the firm's action? And so something we often struggle with is, do we want to be like very sort of tight in how we characterize this action set? Should this action set sort of be like exactly the things that like the firm might actually do? And our current interpretation, especially of sort of the European antitrust legislation, is that it's about potential. It's not, like if something is a thing you could possibly do, that's cause for concern. Okay. Even so, an argument like, but we would never, is not sort of convincing for the reasons that you just said. Weird things happen, right? So like, it makes sense to take the set F to be a little bit larger to account for these kind of unexpected turn of events that could really change things, right? So I think my current interpretation or my current inclination is to let this set F be large, at the risk of possibly making it too large, but at the advantage of identifying possibilities of harm, with this definition, and giving the investigator flexibility in lower bounding this definition by being creative with like the kind of actions they entertain.
That's right. I guess the fear is that by making it too big, then it becomes a vacuous notion, or that everyone has power.
Yeah, but I think our the results sort of even the theoretical results sort of show you it's not vacuous, right? It's like very sensitive
under
to
competition,
the market circumstances, right? It's a very quickly responds to like outside options, personalization, whether you have a monopoly or not, right? It's like if you plug it into market definitions, it is very responsive to what's going on.
Yeah.
So I don't think it's there's any risk of that. But for an antitrust case, of course, you can still always say, look, I think the action you picked is unreasonable, or I think there's no harm here, right? So I think this is not the full case, right? This is really like the boldface part of the investigation, right? Like, let's be clear on what the causal question is that we're talking about, and let's answer this causal question precisely using all the causal inference tools that we have. And that's part of the argument, but not the whole thing, right?
Yeah, awesome. Yeah, so I guess building off of some of what you're answering, for a lot of your work that I am a huge fan of, I think I'm often struck with, after hearing your talks or reading the papers, asking the question, like, is this descriptive or is it prescriptive? Like, are you characterizing what's happening out in the world, or are you saying that we should be doing something? I think of performative prediction as a great example of this, where like, yes, people and sort of social systems are responding to predictors. I guess the question is, what should we do about it?
This is interesting. So I think in this talk, I think of performative prediction as mostly descriptive. Okay, I want people to think of performativity as, you know, something they have in mind when they think about prediction, right? So just like you think about accuracy when somebody says prediction, you know, you should also think about performativity, right? And so in that sense, it's like a way to think about prediction. I'm not suggesting that we should all like do performative optimization. And in fact, we know a lot of like cases where that's not a good idea. It can be a good idea, but we also have examples where it's not. And so it's more a thing to have in mind when we think about prediction. The second part, the definition is normative, right? This is supposed to be like eventually like you know, a definition of power that has some like normative significance, right? And yeah.
Cool. I want to make sure that we're doing okay on time, but I could ask one more provocative question. I guess, okay, so let's go for it. I guess the question for a lot of these things is like, based on your talk, has supervised learning run its course? Has like market economics run its course? Has like modeling these digital firms within the context of sort of traditional notions? Like, should we all switch to performative power?
No, so okay, let's start with the first part. Has supervised learning run its course? I actually think, you know, all of you know this from causal inference. You know, if you do your double ML estimate, you know, like the prediction is still there, right? You're still fitting all the models, right? And it's just you're packaging it differently, right? So supervised learning does what it does, right? And it's very good at what it's doing. So I'm a firm believer in like supervised learning, where what you need to do is fit the data. You know, the second question, this is not meant to be sort of a wholesale replacement of like, you know, all the antitrust stuff. I mean, certainly not. It's like, again, meant to like clarify somehow what we think is like a centerpiece in a lot of these cases, namely what is sort of the causal effect that we're concerned with. Okay? And I think when you're establishing whether harm actually occurred and all the other stuff, that's when, you know, you need other tools as well anyway. And so again, also like all the classical market models, they are useful for like sanity checking this definition, right? This is like how we theoretically figure out if this makes sense.
Great. I think I mean, I may yield back to it looks like there's more Q&A.
Yeah.
And I don't know what time schedule we're on, so.
Yeah, thank you,
Moritz.
Moritz and Michael, for the great discussion. It seems that your discussion kind of stimulates a lot more questions in our Q&A. For the interest of time, I will pick one of them. Is there not logical upper bound to performative power at all? With HHI, which has an upper bound, this helps enormously to get a sense of how harmful a merger should be.
Yeah, great question. So, you know, generally, I mean, upper bound, or even just like the units of performative power is a good question, right? When I stated the performative power of Google targeted advertising, I did the thing you usually do for like elasticities. I expressed it as a percentage of something else. And I think that makes it a little bit more legible, but it's still sort of not always clear, you know, what you should normalize it by and like what the scale of it is. And I think that's where a lot more work could be helpful. And you also mentioned mergers, which is a great case to study. We haven't, you know, I think understanding the interplay of mergers and performative power is wonderful research question. So by all means, I'd love to see more work on that.
Thank you for your answer. Maybe one more question. does this mean that if we want to achieve some changes in the population, such as here's their behavior, we need to create an institution that has performative power?
Yeah, if you want to, if you want to have some sort of intervention, I don't know about the definition of healthier behavior, but if you want some kind of intervention that has like a broad effect, that will inevitably be an example of like performative power. But as I said before, there's this important difference between harm and power. So not all power is harmful in the predictive setting.
Okay, I think it's time to end our seminar now. Thank you, Moritz and Michael, for your wonderful talk and discussion and staying on time. So next week we will have Isabella Hausman and Lily Hu. Both of them are from Yale University, and we'll continue our discussion on fairness and causal inference. I'll see everyone next week.
Thank you so much. Really appreciate it. Thank you, Michael. Bye.